That's the one. A startup out of San Francisco claimed they achieved zero-cost feedstock by using atmospheric carbon dioxide fermentation. They promised they were producing protein at just 10 cents a kilogram, and they claimed they could offer an instant scale-up right to a 10,000-liter facility. It sounds like the silver bullet to solve global hunger and climate change in one fell swoop. But is it real?
Unfortunately, when the bulletin ran the numbers on their claims, the math just didn't align with the physics. To produce 1 kilogram of protein from carbon dioxide, the basic mass balance requires an input of 1.8 kilograms of CO2. Furthermore, the energy required for the biological fixation of that carbon is massive, about 15 megajoules per kilogram.
To put that in perspective for you, 15 megajoules is roughly the same amount of energy it takes to run a standard household electric oven on high heat for an entire hour just to make 1 kilogram of protein.
Exactly. So even if the feedstock is literally free air, the electricity and energy costs to run the process will push operational expenses to at least 80 cents a kilogram at scale, not zero.
Wow, so the core premise is flawed right out of the gate. But what about their yield claims? They reported a yield of 0.75 grams of protein per gram of input.
This is where it defies what we call the Gibbs free energy mismatch. To put that simply for our listeners, it violates the basic accounting of physical chemistry. You literally cannot get more energy out of a chemical reaction than you put in. The absolute theoretical maximum yield for this type of carbon fixation is only 0.55. Claiming 0.75 is scientifically impossible with current biological pathways.
And what about their claim of an instant scale-up to 10,000 liters?
As we discussed earlier with the Novartis example, that completely ignores the physics of mixing time. Jumping straight to 10,000 liters means your mixing time will jump from 5 seconds in a pilot tank to over 30 seconds, which risks a massive loss in production rate due to poor oxygen transfer.
The cells would just suffocate.
Right. So the analytical takeaway from the source material is that without hard pilot data, this appears to be a venture capital pitch rather than a market-ready reality.